Hello, I'm Peter, a Director of Product Management here on the AOS software side. Let me slow down a bit. I've got an hour to fill, so we'll be talking for quite some time. We will take questions, but probably kind of at the end of each slide, try and bundle them up for a bit. As we talk about kind of where we've been taking things and what we've been doing, we still go back to some of those core pillars we've been using for a long time. Simplicity, stability, and smartness, right? Everyone knows the easier the network is to set up, the faster you can make a change, the better it is. You guys deal with them all day. You don't want to spend 10 hours changing transmit power. You want that to happen automatically. Things have to be secure. You listen to Ozer talk forever. Everyone knows wireless is the primary method of connection. I won't talk about it too much, but the question is, how do you keep the network up as much as physically possible, never have any downtime? And that's something we've been addressing in multiple points as we carried through with AOS 8. And then the last piece, how much can we automate? How much can we take out of your hands and just make happen as you would want for you? Still give you the visibility into why it's happening and when it's happening so you can change it and turn it off if you're not happy, but reduce some of that stress and let the network fix itself. So as we've kept those in mind, as we've built AOS 8, AOS 8 does have some significant changes and enhancements towards what we've built. Obviously, you all remember the day of the autonomous FAT APs. You had to configure each one individually. It was a lot of work to bring up a wireless network. Back in 2002, controllers came in. They started to aggregate all that information up, centralize some of the data plane, control plane management, make it much easier to manage a large network. When we built those out at Aruba, we also introduced the master controller. I don't know if you're familiar with it, but basically it starts to aggregate information across multiple controllers, becomes one central config point to push out to all those controllers. You can put 10,000 AP networks under a single master, so you have one place to configure, one place for all the RF information to be shared, the security data to come, and really give you a simple, scalable network. That was great when we first launched, but over the last 10 years, wireless is used much more heavily, and there are a lot of newer services that are coming out. Things like UCC optimization, Air Group, AppRF, ClientMatch are all trying to run in that network appliance hardware. We were starting to see the limits of that, right? It's not built for general purpose computing. It's got a small RAM footprint. It doesn't have any persistent storage. That was starting to hold back some of the services and the features we could build into the wireless network. So with that, with AOS 8, we've made some significant changes. We're introducing a new product called the Mobility Master that really is an evolution, the next generation of our master controller. We're taking that master controller out of a network appliance and putting it into an x86 box. So there will be an x86 appliance that gives us more CPU, more memory, more storage to really tackle these larger service problems. Now that we're also in an x86 box, we're introducing virtualization. So that Mobility Master can run in a VMware environment or shortly in a KVM environment. So it doesn't have to be a physical box, which has been a common request from our customers. As we did that, we've also virtualized the local controllers. So the local controllers are still doing all the data plane management. They're just not doing as many of the services. Those services have been brought up. So the data plane management can still happen in a hardware appliance, which is where you're going to see the best encryption, the best throughput. Our 7240 still has about 40 gigs of firewall through it. But if you want, you can move that into a virtual world. You can run that in VMware and KVM. You get a smaller amount of throughput, 4 or 5 gigs, but you still get very large numbers of APs and clients because you have a lot of CPU and memory there to help you out. So those are two of the really large shifts. One of the other shifts that came in is kind of some of the assumptions around where an AP is terminating and where a user is terminating. In the old world, a user always went through its AP, terminated on the same controller as its AP, and AP terminated on one controller. With AOS 8, users on the same AP can be spread across 4 different controllers. So we can actually load balance users. And the APs themselves don't have to terminate all their traffic on a single controller. You can have SSID 1 go to controller 1, SSID 2 go to controller 2. Those 2 changes, kind of breaking some of the old assumptions and kind of restrictions we'd put in place to make things really easy early on, enable a great deal of flexibility in kind of the feature sets and the deployment models that we can build out. So that's really what we've been focusing on and working heavily with AOS 8, and we're launching today. So if I look at that simplified setup, one of the first things we've done is zero-touch provisioning. So we've had zero-touch provisioning on our APs for a while. We've extended that into the controllers. So this isn't just branch controllers, it's also campus controllers. Whenever you plug that controller in, it'll reach out to activate, figure out who it should be talking to, create a secure connection back to them, and get its full config from the Mobility Master. This makes the mobility master the single source of truth, the single place to configure. Everything automatically pulls down from it, just making it easier to deploy a network. One of the other restrictions we've removed with Mobility Master is today under a master controller, everything needs to be running the same version of code. Mobility Master is much more intelligent. It can actually manage multiple versions of firmware. Now the Mobility Master will need to be on the latest version so that it understands all the features that are out there. But if it's on AOS 8.3, it can manage controllers on 8.1, 8.2. The benefits of that is it means when a new version of code comes out, you can roll it out slowly. Now, one of the key things, the Mobility Master is not in the data path. If you upgrade it, you're not taking down your network. You're not breaking the data flows that are going through. So you can upgrade the Mobility Master independently to the new release, start using it, pick a single site, a single controller, upgrade it, test it for a week, test it for a month, burn it in for 6 months, however long you want, and then start to roll it out to the rest of your network when you are ready. We got a lot of feedback that it's really important to be able to do those things slowly and safely, so we're making that easier. The next one we're calling Multizone. This goes back to the fact I was talking about the APs no longer terminate all their traffic on the same controller. So you can have different SSIDs terminating in different places. This really gives you multi-tenancy in the AP. The initial use case we envisioned were high security networks. I can have an extremely high security network and a low security network, live on the same AP, but terminate on different controllers. That gives you a huge kind of air gap, air wall for the data. Because one important thing to remember in the Aruba solution, we typically operate in tunnel mode. In tunnel mode, the encryption goes from the client to the controller. So what that means with Multizone, I can sniff the traffic over the air, I can sniff the traffic on the wire on the other side of the AP, or even inside the AP if I tried to steal the traffic. It would be encrypted the whole way through. So I get complete security separation, and it's not decrypted until it hits that separate controller. So on my primary controller, where I could put, say, my high security SSID, that primary controller has full control over the access point. It chooses IP address, radio, transmit power, everything, except that secondary SSID. The second controller gets to configure the second SSID and the security mechanisms for it. So it can have full control over its network without impacting the neighboring network. Obviously, this goes beyond just config into monitoring. That secondary SSID doesn't get to know anything about the users on the first SSID or what that SSID is, and vice versa. As I mentioned, it was originally for our high security federal customers that would want to run top secret class networks and regular secure networks through the same access point. Traditionally, that's meant deploying 2 wireless networks, twice as many APs, too much co-channel interference, too many APs and radios beaconing. All of that goes away with Multizone. That was our initial use case. We've seen a lot more interest in guest networks. Instead of running it through the controller and then tunneling it out to the DMZ, put a second controller in the DMZ and know that that traffic is completely separate. It's not just firewalled, it's actually encrypted separately and carried through separately. Any questions on that one? Because that one's actually pretty cool. I'm going to pause here for questions for a minute. Yeah.
What about a failure? What happens in a failure if you're running different versions? Are you going to have like mismatch code or have like a slow conversion of the APs as they try to download the new code?
Hold on to that one. The next slide is stability, and it's all about failure mode. But basically, we'll start talking about clustering a little bit. And when you're within a cluster, you do need to be running the same version of code. So that if one controller fails, the APs will seamlessly just carry over to the next, not have to upgrade or downgrade. And one of the big things we've done with clustering is start doing stateful failover, where we're actually sharing user session state across, so the users don't have to reauth either. But a little preview of what's coming next. So Multizone is really something we're very excited about, has some big implications. And then the last one, just a new UI. When we're talking about simplicity, anyone who's used an Aruba network knows it's incredibly powerful, it's incredibly advanced, very feature-rich, not exactly simple. We're coming in and we're changing that. So new UI gives a new look and feel, but also a new config model. So we still have the profiles underneath that you can reuse all the config you want, but it's now a hierarchical-based config. So I can inherit from above and just override what I need. And we've abstracted away a lot of the profiles in the UI. So you can just click through, turn on what you want without having to know that profile structure by heart. This should really reduce the amount of time it takes to ramp on the Aruba solution and learn how to use it, how to deploy it. And it should make it much easier to make kind of moves, adds, changes, and adapt to what's out there. So with that, I'm actually going to jump over into a quick demo of some of the new UI to give you a feel for what that looks like. And here we go. So this is the Mobility Master. New UI, left style navigation. So over here on the left, I can see that I'm drilled into a specific 7210 controller that's in the Sunnyvale folder of my managed network. I have kind of the dashboard information. I can jump into configuration. If I head over to configuration, I can see all the WLANs that apply to this 7210. You can see there's 3, a Mesh 801, Test, and OSR network. This is a test Mobility Master that we're running. But if I hop up to Sunnyvale, I see there's only 2 of them. 2 of these have been inherited down to the 7210, and 1 has been defined directly on the 7210. I can come in and add a new one. You'll see it looks similar to Instant as we were focusing on the ease of use. But I can come in and make all kind of the detailed decisions I need to make at the same time. So I'm going to set up a guest network just because it's quicker to run through. Well, I'll leave it employee. I get some basic information. Do I want to broadcast? Do I want to tunnel, detunnel, broadcast my SSID? I can choose my VLAN. Right now, there's only 1 VLAN defined. If I want, I can jump into more of the advanced features, see all of my VLANs, create new name VLANs, new VLAN IDs if I need it. But one of the themes we've tried to carry through is to hide that level of detail until you need it. So we can keep it simple, easy for the basic users, but still let the advanced users dive into what they want. Then we ask for the type of security. Obviously, if I was setting up enterprise, I'd need some Radius servers and a few others. I'll drop down to open just because that makes life a little cleaner. And I get to choose my role. As you guys know, the policy enforcement firewall, PEF, in the controller is kind of a key piece of everything we do. I can decide the role that this user should get. I can also take a look at what all these roles mean. What exactly is the authenticated role I'm looking at, or the guest role? What rules apply? So here I can see the individual rules that are for this role. I can also apply global rules, though. If I want all users to not be able to use Facebook, I can come in and set that application rule and block Facebook. I wouldn't do that, but you could, right? You get those options. You can deny, you can permit, you can apply quality of service, all that sort of good stuff from the firewall. Set that up here, one place as you're setting up the WLAN. You're not going to 15 different profiles and 10 different screens as you go through and build everything. So now I have pending changes. I'm going to discard those changes since those are just kind of a setup and hop back out to the beginning. I mentioned that you can still get to all the detailed profiles. So here I can go look into one of the AP groups for a MISH test. Let's go to MISH test 1 where we have an AP. But if I want to, I can still look at that detailed WLAN. If I click over here on the profiles link, I can still get to those detailed profiles that my Aruba customers are used to. I can dive into exactly what's in the AP system profile and start to configure any of those details quickly, easily, and in a straightforward fashion. We tried to give you as much as possible. But like the radio screen, we've combined 3 or 4 different profiles. So I can choose my radio mode, which is my radio profile. I can choose my transmit power out of my ARM profile and my valid channels out of my regulatory domain profile, all in one place to make it kind of simple and easy. And graphically, we tried to make it a little more clear what channels you're using when. Got to click, select the channels that you want, get a feel for where things are applying and where they're not. I mentioned the hierarchy over here, kind of inheriting down. I also do have a Mobility Master object. So this is the manager that I can come in and configure and make any changes to I want. Any questions on that? Okay.
How's the mobile support for the browser on ArubaOS 8?
Much better.
Better?
It has much more of a responsive UI that will kind of rescale. Still not quite as perfect. There's a lot of information in there, and seeing that on a 4-inch screen, you can't really get through all the profiles. But like for iOS, it should be great. So reliability, coming back to this one. One of the features that we've built in is called controller clustering. So basically, you nominate a bunch of controllers to be in a cluster together. They'll be running the same version of code. You can do up to 12 7200 series in one cluster. When you do that, they will start kind of kicking in for stateful failover automatically. Basically what happens is, you're probably familiar with the AP fast failover that we've had for a while. The AP brings up its tunnel to its primary controller that's doing all of its configuration, and it has a secondary controller that it brings up a tunnel to. It just doesn't use it until the primary goes down. The AP can detect that in, I believe it's about 800 milliseconds, so it takes a little while to detect it and fail over. But the controllers are talking to each other and can detect that very, very rapidly and fail over an AP if needed. Historically, or in AOS 6, the client was then deauthed and it had to reauth to get back on the network. With AOS 8, we've divorced the AP from having to terminate on the same controller as the client. So that client might already be on controller 2, and when controller 1 goes down, nothing happens to it. It just keeps going to controller 2. But on top of that, the persistent TCP sessions are actually getting shared across to a backup controller for that client. So the backup controller already knows the auth state, the role, and any kind of persistent TCP sessions. So things like a Skype call won't notice an impact, video won't notice an impact, your FTP sessions will just keep flowing through if there is a controller failover. Network doesn't go down, everything just keeps flowing. So that's one of the really cool things that came with clustering. One of the other things we did when we built clustering and now users didn't have to terminate on the same controller as their AP, we added in user load balancing. So there's a primary controller that gets decided automatically for you in that cluster, and it will allocate kind of MAC address ranges to get assigned to the different controllers. If it sees one controller getting more users than the others by about 5 or 10%, they'll start to move those MAC address buckets around to make sure you get an even user distribution load, which also gives you a pretty even data distribution load through the network. So if you have a large campus and all of a sudden there's a massive sporting event and you end up with 6,000 users in an area where you usually have 300, you don't have to worry about those 6,000 users crushing your controller. It's clustered, those users are spread across your entire network.
Is that whole process predictable?
Yes.
So I know which is going to be the master. I know where the failovers are going to occur.
Yes. So there are a couple different things. The primary in the backup controller is a known state that's actually shared up to Airwave, and it'll be visible in Airwave a little later this year, and it's currently visible on the controller. So you can see the primary and the backup controller for each user and know if this controller were to go down, where would that user go. On top of that, you can get a feel for what the buckets are. So you can see where the buckets have been assigned for the VPN tunnel creation, or for the tunnel creation, I should say. So I mentioned, MAC address 1 could end up on MAC addresses ending in 1 could go to controller 1, ending in 2 to controller 2, ending in 3 could go to controller 1 and kind of split off. You can see what that list is. That list may shift as we load balance users, but you can still see what's there. And it is predictable kind of down to the APs. That primary controller will share down to the APs what that hash looks like, or that mapping of which MAC address goes to which AP, and build that up. So there is visibility into it, and it's predictable, but it will adapt and change based on your networking environment to make sure things stay healthy.
Okay.
Yeah, it's actually really cool. We're very proud of that one. It's working really well from everything we've seen. The other benefit of this is giant campuses. Most of our customers aren't a big enough issue to notice any roaming. Right? A lot of customers can be covered by a single controller. 1,000 APs is a very large set. 2,000 APs, even larger. But we have large universities that may have 10,000, 12,000 access points. Today, when you go from one controller to another, you'll typically reauth, get a new IP address. Or you turn on layer 3 mobility and the new controller builds up a tunnel to the previous controller, and you get a whole bunch of these layer 3 tunnels running around. Scale gets a little rough, gets complicated to troubleshoot. With this model, each AP can build up to 12 tunnels, 1 per controller, and then it'll just shove the users through that tunnel as needed. It'll build those tunnels only when there's users that need it. So if you have very light load on the network, it won't bother with the tunnel. But if I have 100 users on the AP, there's a good chance that tunnel is just going to be up and stay up regardless of the users that are there. So it's a much more deterministic tunnel environment with a much smaller set of tunnels that are there. But the end result is if that user is terminating on controller 2, I can roam anywhere on campus across 12 controllers, and my traffic still goes back to controller 2. I'm never reauthing, I'm never getting a new IP address, I'm never really roaming from that mobility anchor point of view. I'm just moving across APs that all know how to talk back to my controller and send my data there. So it can give you a really, really strong, giant campus roaming experience. Any other questions on clustering?
Do you need to have like an even number of controllers for the XOR process to work?
No.
On MAC addresses?
No.
Okay.
You can have an odd number. That's fine. For the clustering, I mentioned we support 12 controllers. That is on a 7200 series. You can have 12 of those. If you're doing it on a 7000 series, which is our smaller controllers, you can do up to 4. We expect that mostly for lab environments, testing, things you guys might set up to play around with. Not so much for large deployments. And we don't recommend that we don't allow you to mix and match. It doesn't make sense to take a 16 AP 7005 and put it in a cluster with a 2000 AP 7240. From a scale point of view, they just really don't fail over or make sense. So that's kind of where we drew the line. 7200 series together or 7000 series together. Or virtual mobility controller together. That's something I mentioned briefly in the previous slide, but we do allow for virtual mobility controllers now. They will be showing up on the price list probably in November. We're still working on the exact price list date, but you get all the same features that you have in the hardware-based controller, just running in a VM environment.
So it's got full feature parity?
Complete feature parity.
Really?
I'm trying to think if there's a single feature that's not there. I'm afraid saying complete feature parity, but 99.99% feature parity. So we still support tunnel node, AirMatch, ClientMatch, AppRF, UCC, VPN termination, all of the things a controller does, zero-touch provisioning, all that sort of stuff. Michael, do you know of anything we don't support? Yeah.
Is there any major performance hit in any one area?
Throughput.
That's it?
Throughput is the biggest one because we use networking processors that are designed to do encryption. On an Intel chip, even when we use the DPDK, when we start doing the encryption and the DPI, we get 3, 4, 5 gigs of throughput depending on the CPU, which is significantly lower than we see on a large controller. But we feel that restriction has been somewhat alleviated with clustering. So you do have the option, you can bring up one VM. If you start to get up near 4 gigs of throughput, bring up a second VM, add it to the cluster. You don't even have to move your APs over. Your users will start to balance and it'll take up some of that throughput. So you've effectively doubled the amount of throughput you have. Add another for redundancy. And the way we're structuring our VM licenses, we're not charging you how many VM servers you bring up. We're charging you for the capacity of APs that you're managing. So if you buy a VM license for, or I think it's going to be I'm going to try and get the name right, a mobility controller virtual appliance license for 1,000 APs, you can apply that on the mobility master and you'll get the centralized licensing feature to kick in.
You could have 500 VMs all running 2 APs each.
Yes, I could have one doing 1,000. I could do 2, 500, 500 with full redundancy, or I could be a distributed enterprise and bring up one in each individual site with 2 APs there. To us, the important thing is how many APs are you managing, how big is your network, bringing that back to Mobility Master. Now, if you're running that VM without a Mobility Master or without access to one, you apply the license directly to the VM, and then you're limited to whatever that license number is. But if you apply it to Mobility Master, you get that flexibility to deploy what you need when you need it. Which is why when I was saying just add another VM, it's literally, you don't even talk to us. If your VM stack has an extra server lying around, drop it in, you've got more throughput.
So are you seeing, like, in the future where we just dynamically spin up additional controllers as we need more load or more throughput?
That would be a really cool feature. So we're not quite there yet. The AP load balancing isn't there, but that's something that would be very interesting for us to build, and we would be very excited to build.
You said right now it's VMware, KVM coming soon.
Yes, so KVM, we're adding support in 8.0.1. And the virtual mobility controller itself is coming in 8.0.1, which will be in a few months.
You could potentially orchestrate that yourself.
We could. You can see we've done a lot of work in here. There have been huge changes to kind of the data flow, the kind of assumptions we were making on where traffic is going, clustering got added in, moving to x86. So it really is, when Ozer said kind of the foundation for the next 10 years, this really was kind of the foundation of the architecture. Everything that you're talking about are things we've thought about and we just haven't been able to get to yet. And they're things we want to grow into, and this architecture gives us the ability to get there. And that's why we're really, really excited about it.
You add a virtual appliance to a hardware cluster?
Today we've only tested virtual appliance, virtual cluster, hardware appliance, hardware cluster. We have some testing to do and some work to do to get there. So I can't give you a complete answer, but it's something we're looking at.
Okay.
Cool.
Quick question.
Yes.
A lot of moving parts.
Yeah.
When it comes to troubleshooting a client issue, can you talk about that a little bit?
Sure.
I mean, because all these tunnels and different controllers in the cluster and all that.
So all this information is going to be making it up into Airwave. So Airwave will give you the ability to see what is my cluster, how many controllers are there, what's the throughput, does it have scale, how are they performing? And on an individual client, you'll be able to see who's my primary controller, who's my backup controller. While there are moving parts, I don't really expect users to get load balanced every 5 minutes, right? We're talking a difference of 5 or 10% of user count on the controller. So for larger controllers like a 7240, 5% of 32,000 is you need to have 1,000 users delta before you start load balancing. So it shouldn't happen all the time, but it should be there to kind of be a safety net. And just like controllers shouldn't go down all the time, so you shouldn't be falling over to your backup. That should be a rare event. So it should still be very predictive and give you a very good feel, but you will have all the visibility into the backup in Airwave. All of that is also on the controller, so you do have the option to drop into the CLI and look around in the CLI. There's a large set of features that didn't make it into this list that we're going over. They're not giant boulders. One of which is in the CLI, we added profile name tab completion, finally. It was one of the largest requests from our customer base, so we were very excited to get that in. We also multi-threaded the CLI. So if you run a tar log tech support, you don't have to wait for that to finish before you issue other commands to start debugging. So we've definitely had a focus on debugging. There's a lot more visibility in the CLI. You have that option. We're just trying to make sure our average users don't have to use that option and get it all into Airwave. Any other questions? Okay. Another one is Clarity. So Ozer mentioned this. Hopefully many of you have seen the kind of Clarity Live beta on Airwave. So the idea behind Clarity was we got tired of hearing everything is wireless's fault. Why is the wireless network broken? Help me troubleshoot it. Historically, we'd always done the RF, right? If we went back those 10 years to 2002, people only expected us to troubleshoot the RF. Everything else was the wired side's problem. Now that wireless is the primary method, if DHCP isn't working, it's the wireless team's problem. DNS isn't working, it's the wireless team's problem. So we've added Clarity Live, which gives visibility into all of that wired traffic. Well, all those kind of network services, I should say. Basically, every DNS request, DHCP request that goes through the controller gets timestamped. All the responses get timestamped. We keep track of which servers are responding and when. So we get a great view into the live data through your network and how healthy things are. The problem is, remote sites, you don't always have a user. 2 a.m., you don't always have a user. You can't tell and make sure the network is up. So we're introducing Clarity Synthetic, which gives you the ability to have a radio associate to a neighboring AP and run a bunch of tests through the network. When that happens, you get all the great association tests. I can associate, authenticate, get an IP address, get DNS. Then we can ping back through to a known system, make sure ping works, run trace routes, see that they're healthy. Then we can do iPerf. Just do a baseline RF performance test to get a feel for what's out there. Now, it won't be exactly what your end users see because you sitting on the table have a different RF path to that access point than those two APs that have line of sight on the ceiling. We understand that, but we'll have a baseline for those two APs today and last week. And you can look at the graph and see how they compare and know, has things gotten worse? Have things gotten better? Have they changed? We're also going to add in we've also added in the ability to do web page load. So you can specify a URL. We use Salesforce. I can say, does Salesforce load in under 3 seconds? Now, I don't know why Salesforce isn't loading in over 3 seconds. It could be their servers are slow. It could be my WAN is congested, or it could be an RF problem. The important thing is we're trying to identify that end user experience issue before they call in. Because a lot of times they don't call in. They just complain amongst themselves. I mean, everyone's had that problem where Outlook isn't working, and instead of calling IT, we complain to the guy sitting next to us. Can't believe Outlook's broken again. Why isn't the server responding? Right? It's just human nature. So we want to be able to test that, see that it's happening, and report on it ahead of time so that you can get those kind of alerts and visibility. So with Clarity Synthetic, there are a few different things going on. Obviously, we had to make some changes to the AP code so that the AP is capable of running these tests. We're also introducing a Clarity server, which is really the testing endpoint. So that'll be just part of the solution, and it comes up. You'll install it as a separate VM, but that's where your iPerf tests will terminate. That's where your pings will terminate. So you can get very deterministic tests and not worry that running a report on Airwave is affecting my iPerf results. So it'll be kind of a segmented, separated area for now. Any questions on Clarity? Was this all stuff you're fairly familiar with? We've been very excited about Clarity for a while, so we haven't been good at keeping that one a secret.
Which test does the test server support? Just iPerf?
So the test server, whenever you're running synthetic, the test server is actually using the radio and the AP as an extension of the server. So it's sending the .11 frames over the wire out. So it's actually involved in all the tests. Ping, traceroute, iPerf, association, page load, everything is originating from there. Now, as you can imagine, since that is a Linux box running a VM, we actually have a very large suite of tools we could run now that we essentially have a remote radio that we control through the server. So there's a lot of stuff we want to add into that. We're not quite there yet. Again, foundation for where we want to go. But we could, in theory, eventually get to the point where we're actually running a live Skype call through the network, or running custom tests through the network where you script up whatever you want Linux to do, and it'll go do it and print out the results. Those are long-term visions. We're not there yet. Today is that set that I was talking about. Ping, traceroute, iPerf, page load, DHCP, DNS, authentication. That sort of kind of core stuff to make sure the network's up. We think it's a pretty good list and a good start.
And Peter, using your Salesforce example, you're saying we don't know where that bottleneck is, but if I have a full Aruba network, can I see that whole path that radio's talking to from like switch to switch, and between these switches is where we're seeing that latency issue?
So another area where we're not quite there yet, but would make perfect sense, would be for switches to start to be a part of Clarity as well. That would be a wonderful roadmap item for us. But we're not quite there in this launch today.
Right, thanks.
I might have missed it, but did you mention anything about scheduling some of those tests out?
So the scheduling piece actually won't be part of the Clarity server. Okay. That'll be part of Airwave. And I'm trying not to talk too much roadmap. It's hard because we get really excited. The person I would ask about that is actually up next, talking about Central, Pej. Ask him a few Clarity softball questions, and he may be able to throw in some answers. Cool. So then one of the last pieces is in-service upgrades of services. So with the Mobility Master, we have a lot more compute and memory. I keep saying that, and I keep coming back to that because that allows us to do a lot more. So things like Air Group has been brought from the controller into Mobility Master. ClientMatch decision-making logic is stored in the Mobility Master. A few other things have been pulled up. With this, I can now upgrade those chunks of logic without upgrading the OS on the controller or the AP. So if iOS 11 were to come out, and for some reason the Apple devices started behaving very strangely and not working with ClientMatch, we could come out with a new version of ClientMatch that updated, used them more effectively. You could apply that change to the Mobility Master by doing an in-service upgrade of ClientMatch. You would not upgrade your controllers. You would not upgrade your APs. Your network would never go down. ClientMatch would just get interrupted for a minute or two, start back up, and then have the new behavior. So we're moving to the model of being able to upgrade some of the intelligence and the functions of the network and the decision-making process without affecting the controllers and the APs. Now, obviously, that won't be everything, right? If I'm changing when I make a move, I can do that without affecting anything. If I change how, the controllers and the APs are going to have to update, right? When it's some of that data path and they need new hooks that they haven't had before. So there will still be the occasional upgrade that does require a controller or an AP to be updated, but we'll be able to make some changes without it. This goes back to that stability, right? There are a few reasons networks go down. We're to the point where a controller outage causes no impact. If you have a switch outage, our AP335 gives you hitless PoE failover and just starts using the second PoE port without rebooting. If you have an AP outage, your clients roam to the neighboring AP because you should have good coverage, so you have multiple APs in any spot. And now if you have That kind of left the planned network outages where I'm going to make changes and upgrades. And with this, we can reduce those. Not fully eliminate them, but reduce them. So we're trying to knock down each one of those one by one to make sure the network can really, truly be up as much as possible for our users. Any questions on any of that? Back too far. I know we had some as we went. Just wanted to make sure. How am I doing on time?
21 minutes.
OK, perfect. So then kind of automation and extensibility. AirMatch is another very large feature we're introducing with AOS 8. You're all familiar with ARM and kind of the channel and the transmit power planning we've done for a very long time. When ARM was built, it was a different world. It's a strange thing to say, but when we built ARM, RF was not ubiquitous. We weren't congested on every channel all the time. People weren't carrying around 4 or 5 devices with them on the network all the time. IoT wasn't a thing. We weren't worried about my watch and the refrigerator and my shoes deciding to be on the wireless network. All of that has changed. And with that, that means every channel is busy pretty much all the time. So the original ARM we had built was really designed around finding the best channel for you, the healthiest one. With AirMatch, we flipped that a little bit, and we're now prioritizing kind of channel reuse, making sure we have good use of all the available spectrum, even if that channel isn't perfect, because we need to spread out and make sure we're using everything that's there. So with ARM, there were kind of 2 different modes the AP ran in. There was when no one was associated to the radio, and it would hop to the best channel as fast as possible, as often as possible. And then there were users associated, in which case we only changed when there were issues on the network. We've kept that user association behavior. If we see problems on the networks, we still move away from it. But each radio will not be trying to optimize itself all the time. We'll look at the system as a whole. So Mobility Master is actually starting to do the math of looking at sets of 50 APs. What is the best combination of transmit power, channel, and channel width for this environment to give me the most channel reuse and the most capacity and the best network? So it's a slightly different function. We're doing that on a regular basis, but not every minute. Right? Once a day, we're going to go through, look at all the traffic we saw over the last day, all the RF information we saw over the last day, and pick what's going to be the best distributed channel system, channel plan for that network. If it's better, we apply it. Then if issues arise, DFS, the radio will still change independently. But the network as a whole is planned together on a regular basis. And the big thing that we've been adding in for us is channel width. Historically, we've said if you're in a dense environment, like a 500-person lecture hall, go 20 megahertz channels. If you're in a sparse environment, go 80 megahertz. Somewhere in between, go 40. Now we actually pay attention, and the APs listen to how many other APs they hear around them, how dense the environment is, and they make the decision between 20, 40, and 80 megahertz. And again, I know you're going to ask, all that information is being logged, shared. You can see every time we make a channel change, why we made the change. All that will be in Airwave. So we're excited about that. We think it's really going to be more effective in kind of the dense environments and the complicated RF environments that we're seeing today than ARM's channel and transmit power planning has been. So ARM, just so you guys know the terms, we use them. ARM is still our overall radio management term. AirMatch is going to be kind of the channel transmit power, channel width planning. ClientMatch is the client steering piece. So ClientMatch and AirMatch are part of ARM.
Is that going to be tunable at all? Like if there are certain areas where it may not be reacting exactly how I want it to?
Yes. We're going to be following very much the same philosophy we did with ClientMatch. In the UI, it's going to seem like there's one button because we don't want people tuning it and breaking everything. In the CLI, you can get in and tune whatever you want and make whatever tweaks you want. So you'll still have some lower level knobs that you can touch, but in general, we're going to try and keep you from tuning as much as possible by having a good decision process.
In the CLI, will you be able to get a lot of insight as to why it's making its decision?
That I have to double check. I'm not sure how much detail the solver keeps. So the solver will come through and we calculate some internal synthetic metrics for channel reuse and overall health. That'll be visible. I'm not sure we'll be able to see for each individual AP, why this channel was chosen versus the one next to it. Because it's trying to look at all of them together, and that becomes a very large, complicated web of signal strengths to other APs when it's making decisions like that. If it's an event, if it's a DFS event or an interference event that causes a channel change, that you would definitely see. But when the solver comes through, I'm not sure we're going to be able to give that detail. So as you can imagine, that one's taken us a fair amount of time. We know, as you all know, it's a complicated thing to get right. And so we've been spending a lot of time on it, a lot of work there. Another thing that we've heard is there's a desire to work with other systems out there. So with Mobility Master, we're aggregating a ton of context. Was anyone familiar with the ALE product, the ALE product from Aruba? OK, perfect. Those APIs that we had in ALE, which were designed to give you the full context of the user, not just username, IP address, signal strength, but also applications, role, throughput, how much traffic they sent to Facebook, all that sort of stuff was available in ALE. Those core APIs have been moved into Mobility Master. So you no longer need to install a separate server to get that out. Now, we're not doing the location calculation of ALE. That piece is not there. That's very resource intensive. It needs to be separate. But the APIs are there. So if you want to integrate this with any other system, we have REST-based APIs that you can go in and pull the information that you want. Or we have a kind of a publish-subscribe model where it's a 0MQ data feed with protobuf formatted data that'll just come out and give you all the context of the users. You can build your own database, store all of it, parse it however you want, do whatever you want with it. A lot of our large customers, I mean our extremely large customers, 10,000 APs and above, are very interested in getting access to that data and starting to play around with it. But we're not just sending data out. We've also added config APIs. So we can allow you to reach in and configure the network in a programmatic way through Mobility Master. Again, some of our large customers, our service provider customers, really wanted the ability to script up their own system and then just have APIs to reach into to configure the network, set up SSID, set up authentications, all that sort of stuff. So that's in there as well. We're pretty excited about that. We think it opens up a lot of possibilities, and we'll see where people want to take it. And then the last one is an enhancement to AppRF. So you're all probably familiar with AppRF. It does full deep packet inspection, web content filtering, IP reputation, geolocation. Now we've added the ability to kind of custom classify URLs so you get your own app definitions for web apps. So if you have internal websites that you've built or internal tools that you've used, you can now classify those. Additionally, you can build your own custom app categories. So if students use 5 different apps, you can add those 5 different apps into the student category and prioritize it in a certain way, or do whatever you want with it as a set of apps. If you add a new one, you can just drop it into that category, not have to worry about it. Another thing we did with Mobility Master is the updates to app definitions can now be updated like antivirus updates. You don't have to get a new version of AOS code. You don't have to upgrade your network. You can just pull in that app update, apply it, and it'll push down to the controllers, and you'll get new definitions and classifications. So again, going back to trying to eliminate reasons for downtime, reasons for upgrade, make it easier to improve the network without causing issues. There are a few other features that didn't make it in here. Well, there's a host of them. We added IP fix support. We added Jabber visibility into the UCC side. I mentioned the multi-threaded CLI, the tab completion of profile names. We've been doing a fair amount on branch over the last few years. So we added WAN link aggregation on the back of a controller to go with the policy-based routing, WAN health check, link failover, and a few other things that we've built into those controllers. One of the other kind of subtle shifts on the configuration side, master controllers used to push down just the global config. You still had local config that you had to configure directly on the local controllers. That's gone. Mobility Master completely configures everything on any controller underneath it. So you don't have to worry about doing anything on the locals with the zero-touch provisioning.
You said the tab completion of profiles. Mm-hmm. I saw that, and I don't think that gets enough spotlight.
It doesn't. It's one of those that's tough because it's really only people that have used the Aruba system know how valuable it is. So for anyone who hasn't, we have profiles in the system where you set up your radio profile. You name it whatever you want. And I could say, this is the 1344 building. I could say 1344 radio profile. Now, every time I want to make a change to all the radios that are in this building, I just update that profile. Very powerful, very easy. It just became a pain to remember when I'm typing out 1344, did I capitalize radio? Did I lowercase it? Did I get every single character in? Now you hit 1344, hit tab, we fill out the rest of it. We've done tab completion on commands for a while, but we weren't doing it on kind of the user-definable profile names. We've added that in, which we're really excited about. Small thing, but we've been hearing it from customers for a long time, so we're very excited to roll that out, which is why I brought it up. Marketing was like, it's not big enough. It's not a cool feature, but I think it's a pretty awesome simplicity benefit for what's out there. I don't know if I mentioned IP fix support is coming in with Mobility Master. Probably a few other things, but